So worksheet 12 and 13, we're starting talking about graphing rational functions, okay? Those crazy rational expressions that we were adding and subtracting, multiplying and dividing last week, we're going to just graph one little rational expression at a time. Okay, so the learning targets are to accurately graph a rational function, identify zeros, vertical asymptotes, and holes, and predict end behavior, including horizontal asymptotes, oblique asymptotes, and other end behavior functions. Now, you did some of this in Algebra 2. I believe you did some, for sure, in Honors Algebra 2. I think in all Algebra 2. But in the past, when something didn't have a horizontal asymptote, you just said that. Okay, you didn't have to go beyond that. So we're going to go a little bit beyond that. In the same way, finding a hole, if you did this before, I'm not even sure how much of it they did last year. So we're just going to go with we're learning, okay? A rational function is the quotient of two polynomial functions. So you're taking a polynomial on the top and a polynomial in the denominator, and you're going to figure out what happens. The domain is all real numbers except those that make the denominator 0. Do you feel like we've said that about everything all year? Okay, so the domain is everything except what makes the denominator 0. That's not a news flash, okay? One of the simplest rational functions is just called the reciprocal function. That's this one. We did that in our parent functions. Okay, that's just a 1 over x. The lines, the x and y intercepts in this picture are called asymptotes because the graph will approach them but not touch them, okay? Now, eventually we're going to talk about the fact that when we have a horizontal asymptote, it is actually possible, she's here, it is possible for the graph to cross it. It just means its end behavior is staying near the graph. That's the horizontal ones that go this way, okay? Once in a while, a graph will cross it and stay near it. The vertical ones you can never touch because those are the ones where the denominator would be 0. Okay. Graphs of rational functions. I think this might be the top of your notes. Have asymptotes, which are lines that a graph approaches. Vertical asymptotes are never crossed, but a horizontal may be crossed, but end behavior stays near that horizontal asymptote. Okay. Now, if you have two vertical asymptotes, eventually, it means the graph has 3 distinct parts. There's something over here, something in here, and something over here. I say that because it's very easy on your graphing calculator to miss parts of it, okay? We know our graph only shows usually like 10 to 10, right? So we got to be careful to look for other pieces sometimes. All right. What are we talking about here? Just the fact that this is a vertical asymptote here, and its equation is x equals 0. It is the y-axis. You're going to have to know the difference between vertical and horizontal and the equation of both x and y-axis, okay? The horizontal asymptote, being the x-axis here, has an equation of y equals 0. Anybody questions about that? It means every point on the x-axis has a y-coordinate of 0. All right. Now, we are going to talk about the rules of how you graph these and the things that are true. These are also on the reference sheet. For sure, on the first quiz we do this on, you will be able to use the reference sheet, but please do not write extra things on it. Okay? There is a copy of the reference sheet in your notes. Can anybody look? Is it, I think it was like the previous page maybe to this. 11B has a reference sheet. So if you want to take 11B out and use it when you're doing homework and scribble extra stuff on it, that's fine. Does that make sense? But for the quiz, you're going to use that peach one and you can't write extra things. All right. It says when you have a rational function where you have one polynomial on top of the other, okay? P is going to be our numerator and Q is going to be our denominator for purposes of this explanation. If they have no common factors, okay? Other than 1 would go into both of them. And P is the degree of the top and Q is the degree of the bottom, okay? Then all of the following rules will be true. If there are no common factors, it means they don't have a whole, okay? And we're going to talk about that when we get to the back of the worksheet. All right, so when we have a polynomial on the top, I'll do an easy one. I don't know that that's that easy, but if this is our function, what is the degree of the top and the bottom? Exponent power, right? Degree of 1. The vertical asymptotes happen when the denominator is 0, because that's a place where the domain is undefined. So we would, if we were finding the domain for this, we would say 3x minus 1 cannot equal 0, x cannot equal 1/3, but that means our graph will have a vertical asymptote at x equals 1/3. Now, that sounds contradictory. Normally, this would mean I would make you write, okay, that's the domain, everything but 1/3. The vertical asymptote at 1/3 is a boundary. It's not actually part of the graph, okay? It's where the graph goes up to. You will have to sketch it as a dotted line on the graph. I am not going to make you write the domain this way, but that's why it's a little confusing. It says here, x cannot be 1/3, and we write here the vertical asymptote is at 1/3, and that's because it is just a boundary. All right, moving on. Now, the horizontal asymptotes, okay, any horizontal boundaries or end behavior ideas have to do with the degree of the numerator over the degree of the denominator. We're going to talk about bottom heavy, equal weight, and top heavy. Does anybody remember that from another class? That terminology at least? Okay, so you had a little exposure. When you have something like the one I just was talking about on the last slide, this was degree 1 over degree 1. It's the degree we're talking about, okay? Degree 1 over degree 1. That is called equal weight, okay? Then the asymptote, the horizontal or end behavior, will approach y equals c, where c is the ratio of the leading coefficient of the numerator over the leading coefficient of the denominator. So if I go back to this example, the leading coefficients were 2/3, so the horizontal asymptote would be at y equals 2/3. It's the leading coefficient of the top over the leading coefficient of the bottom. If you have an equation that is bottom heavy, for example, 2x over x squared minus 6, this is a degree 1 over degree 2. Does everybody see that? We're talking about the exponent power. Okay, this is a bottom heavy example because it is degree 1 over degree 2. So there are more powers of x in the denominator. So if you put a really big number in there, like 1,000,000, you'd have 1,000,000 over 1,000,000 squared. That's going to be a really tiny number, even though 1,000,000 sounds really big. When you square 1,000,000 and divide it, it gets very tiny. So therefore, when it is a bottom heavy function, it will approach y equals 0 because the numbers will get really tiny. So the horizontal asymptote is y equals 0, which is the x-axis. Does that make sense? A little bit to anybody? If you put even a 10 in here, you would have 20 over 94. That's less than 1, right? So it's going to get tiny when it is bottom heavy, when there's more powers of x in the denominator. All right, the third possibility is that it is top heavy, and this is the one that in the past you may not have had to deal with. And I don't know that this factors, I don't really care. This is degree 2 over degree 1. Everybody okay? degree 2 over degree 1. That is called top heavy, okay? In the past, you would have simply said there is no horizontal asymptote. We're not going to get away with that anymore. If the degree of the top is 1 more than the degree of the bottom, there'll be a slant asymptote or an oblique asymptote. You can call it either one. It means that the end behavior looks like this. So when you graph it, it'll probably have a vertical asymptote somewhere, like here. And the behavior of the function looks like this. What it means is if you zoom out, all you're going to see is this line and one little break in the middle somewhere. That's why the end behavior is approaching this oblique or slant asymptote. And I will show you how that looks on the calculator. The bottom line is, if you go to the very last part here, it says if P and Q are not 1 degree of difference, the end behavior is nonlinear and found by, it doesn't matter whether it's linear or nonlinear, you find this by dividing the top by the bottom. Now, could I use synthetic division if I was doing this problem right here? I'm dividing by an x minus 3, so I could do 3, 1, negative 1, 2, bring down the 1, multiply, add, multiply. Good news. What did it say right here? Yep, we just get to scratch that out, and the line it would approach would be y equals x plus 2. Okay, that's going to be our asymptote. All right, we'll deal with all these options. It does say that you can have things that are nonlinear. So if I had an x cubed up top over an x, when I divide that out, anybody know what the highest power of x is going to be left over? An x squared, right? Because you're dividing an x cubed by an x, you're going to end up with an x squared. It's going to be a parabola shape. We won't do a lot of those, but there are some where the end behavior approaches a parabola. It looks like this. You graph it, and all of a sudden, it looks like this. Well, if you were to zoom out, it looks like a parabola, except it has a break in the middle somewhere. All right. Now the nitty-gritty stuff. The x-intercepts, where it crosses the x-axis, has to be where the numerator is equal to 0. Does that make sense to anybody? The only number, whoa, didn't mean to graph. The only number that's going to make this 0 is negative 6. Does everybody see that? Because you'd have 0 over negative 9, which is okay. The top has to equal 0. If I put another function up here, now negative 6 and 1, okay, are zeros. They're not asymptotes, they're zeros when the top equals 0. The y-intercept, same as all year. The y-intercept is when x equals 0. You put a 0 in. So if I were to put a 0 here, a 0 here, and a 0 here, I'd have 6 times negative 1 divided by negative 3. So this would come out positive 2. Did I do that right? So there I'd have a y-intercept of 0, 2. Okay, so you put in x equals 0 to find that. That should make sense as well. All right, here's an example. It's all done for you. I'll talk you through it real quick. The domain of this is everything except what? X plus 3 cannot equal 0, right? The denominator. So the domain is x cannot equal negative 3. Then we move on and talk about a vertical asymptote. It is the same place, whatever the restriction was to the denominator, that's where there's going to be a undefined place. So the vertical asymptote is at x equals negative 3. So that's here. This is some funky graph paper. They're counting by 2s, I think. All right, the horizontal asymptote is where you look at the degree of the top and bottom. Can anybody tell me the degree of the top and the bottom? What is the power of x? 1 and 1. Everybody good? There's an x to the first and an x to the first. So that is an equal weight. And the rule for equal weight, look at your Peach sheet. Make sure you know where to find that. Look for the words equal weight. When they are equal weight, the rule is y equals leading coefficient over leading coefficient. What is the leading coefficient of 2x minus 1? 2. What is the leading coefficient of x plus 3? It's whatever's in front of that exponent power of highest, so it's a 2 and an x or a 1 and an x. Now, that reduces to y equals 2, and that's where the horizontal asymptote is. Then the other things I will ask you to find are any x or y intercepts. So if you set the top equal to 0, you will get the x-intercept. So we get x equals 1/2, and that's right in here. It's crossing at 1/2. All right. The put in a 0. When x equals 0, you will get the y-intercept. So if I put that in, I would have 2 times 0 minus 1 over 0 plus 3, which would become negative 1 over 3, right? That was a 0. And negative 1/3 right down here is where it crosses the y. That's crummy example as far as they counted by 2s, so you can't even see where they are. Okay, let's try one. And then, by the way, then to get the rest of the shape, you just throw it in your calculator. But super important, you have to have a whole bunch of parentheses on these. You're going to put a parenthesis around the top, then you're going to say divided by, and you got to put a parenthesis around the bottom. And you want to put it in unfactored form when you put it in your calculator, because that way if you factored something wrong, it might show up. And it's also way easier. If you have factors, you've made something a bunch of factors, and now you want to say all that is on the top, you'd need yet another set of parentheses, okay? So put it in as unfactored. All right. I think I'll skip this one. This was an extra example I was going to do. Let's just get you guys involved because I feel like we're falling asleep. Because I'm falling asleep. Too much talking. Okay. The first thing you do, can you go down the list on your sheet? I think I wrote the reference sheet in an order. What does it say to do with the very first thing? Y-intercept? Is that what it says first? Okay. So the y-intercept is when you just put in x equals 0, okay? So put in x equals 0. The reason that's easy is because if you do it before you factor anything, it's way easier. So I would have 0 plus 2 over 0 squared minus 6 times 0. I think that's 2 over 0, isn't it? Is that allowed? No, so this one doesn't have one. Because you can't divide by 0. Everybody okay? Can't divide by 0. Okay, that was really helpful of me to start you out in order. But what's the next thing on the list? Completely factor. Okay? So if I look at this, it does not factor on the top. On the denominator, how does that factor? X and x minus 6. Okay, what is the next thing on the list? This is on the Peach sheet. I want you to be familiar with that reference sheet. The next thing is the domain restrictions, right? You say this denominator cannot equal 0. What are the two values that would make that 0? X equals 0 or x minus 6 equals 0. So we have 0 and 6. Those are not in the domain. So for the domain, you would state x cannot equal 0 or 6. You always do the domain before you cancel any factors. If there is a factor that cancels, that means there's a hole. And then it's not a vertical asymptote if it's a hole. But this one doesn't have any factors that cancel. So therefore, there are vertical asymptotes at the two places that make, is that the next thing on the list? Hole, okay. If there was a common factor, we'd have to talk about that next, but there's not. So what's left over, common factor would mean like if there was an x minus 6 on the top and an x minus 6 on the bottom, okay? This does not have that situation. So therefore, everything that remains in the denominator is a vertical asymptote. X equals 0 and x equals 6. So real quick over here, x equals 0 is the y-axis. Oh, it's counting by 2s. X equals 6 is this guy. So there are the two asymptotes. And you draw them as dotted lines because they are boundaries, not actually part of the graph. All right, then what does it say on your sheet? X-intercept maybe? X-intercept is when you put in x equal, you set the numerator equal to 0. So if I set x plus 2 equal to 0, I get -2, and if it's an x-intercept, the y value is 0. So we have -2, 0. Remember, it was counting by 2s. So it crosses over here somewhere at -2. Remember, it didn't have a y-intercept, which makes sense now, right? Because we have an asymptote there. It means it can't cross that. Can't touch that, okay? Now, what do we got left? That top heavy, bottom heavy business, right? That's the last thing on our list or not? Did I miss something? It's the last thing? Okay. So the end behavior or horizontal asymptote of some kind is the last thing on our list. So we need to decide what is the degree of the numerator. 1, because it was just an x to the first. Now before we factored, because some of you were not good at the leading term test where you have to look at something that's already factored and figure out the degree. But this one given to us already had the degree as an x squared or 2. Everybody okay? And what is the rule when it is degree 1 over degree 2? That means it's bottom heavy. There's more x powers on the denominator. Yep. It just says it approaches y equals 0 as a horizontal asymptote. Now, again, let me try to make sense of that for you. If I just put in a 10 right here, I would get a 12 on the top. I would get 100 minus 60 in the denominator, which is 40. But if you have 12 over 40, that's still less than 1, right? It's getting very small. So when you have more powers of x in the denominator, it's going to get very small. That's why that's happening. Okay, so y equals 0. Sketch this. Now, is anybody already confused? There's an asymptote, and we have a dot on the asymptote, right? Remember I said it can touch a horizontal asymptote. It can't touch a vertical asymptote. All right, now we're going to put it in our calculator, which I don't have fired up. What is the big deal when you put it in your calculator? Parentheses around the top, parentheses around the bottom. Was it x plus 3? X, what was the top? Okay, divided by quantity, and we want to put it in unfactored form. Was it x squared plus 6x? Thank you. I knew it had 6. That's the best I could do. All right. Any questions? Everybody getting how you have to put that in? All right, if I do a Zoom 6, these are really a problem for students. Very misleading. Does that look like it stops? Very much, a couple places, right? There's a couple things we can do to try to help with this. There is a Zoom called Decimal that helps with this a little bit. It looks a little bit better, but it still looks like it stops, right? And this piece is kind of cut off. What the Zoom Decimal does is it tries to help with the number of pixels in the screen. If I change this to a multiple of that, like I'm just going to even try a 12. That one looks pretty good, right? But that was me messing around. It's fine for you. You just have to understand these graphs never stop in the middle of nowhere, okay? Now, if you have an older calculator, especially some of the really old ones I loaned out to people, it thinks that when you get to the top of an asymptote, you connect it to the bottom of the next one. Does anybody's look like that? For this, okay, this one was here. Is that right, guys? And we're going to have to trace to figure out. Do you see it barely crossed here and stayed right below? Okay. You could trace over there. Okay, I'm just going to go to -2. And then if I keep tracing, it's just below the x-axis. Do you see that? Okay. And then over on this one at positive like 6 and beyond, over that way. By the way, 6 is undefined. It's not going to find anything. But if I trace to the right, it stays above. All right, you could go to the table and find a few values, even if they're decimals, like 5 is at -1.4. I don't, this is graph papers counting by 2. Let's just throw this on here. It looks like that, and it looks like this. I don't even want to mess with this. Okay. What was I going to say? Something about, I don't know. All right. This one did not have a hole. Let's proceed and see how we do on the next one. Just to remember, when you have two vertical asymptotes, it means there's 3 parts to the graph. There has to be something to the left of and right of each asymptote that's vertical. Okay? Vertical asymptote has to be something to the left and to the right. All right, I think you finally get to write some stuff down. You don't even have this, I don't think, and I'm going to go through it. I just want you to use your reference sheet. Okay, state the domain of each and the equations of the vertical or horizontal asymptotes as any. So you don't have to do x-intercepts, y-intercepts, or graph on these. Yes. Yep, this is where you should be writing these down. I think it's at the top of the next page, right? Okay. Domain. Set the denominator equal to 0. Okay, x squared plus 1 equals 0. Does that have real solutions? X squared equals -1 by square root. Those are imaginary, right? Anything I put in there in square and add 1 to it is never going to be 0. Does that make sense? So there is no domain restrictions. I'm just going to write domain is all real numbers. Is that easier? Domain is all real numbers. And that means there's no vertical asymptotes. Why is my pen doing funkiness? No vertical asymptotes, okay? What about the horizontal or end behavior function? What's the degree of the top, guys? How many powers of x are up there? 0. It is degree 0 over degree what? 2. What is that called? Bottom heavy. And a bottom heavy will always be y equals 0. That's all they wanted for this, right? Okay, let's try the next one. Domain restriction. The denominator cannot equal 0. So we get x cannot equal what? -1. Is everybody okay? The vertical asymptote is then that boundary where that's true, which is the line x equals -1. I know we just said x can't be -1. It's not, okay? But that line, that asymptote, it doesn't ever touch, is a boundary there at x equals -1. Horizontal asymptote has to do with the degree of the top and the degree of the bottom. What do we have? X to the first over x to the first. So what is that called? Yeah, it's called equal weight. So we do y equals leading coefficient over leading coefficient. What is the leading coefficient of the top? 2, and the leading coefficient of the denominator is just, so we have y equals 2 would be our horizontal asymptote. Okay, number 3 is factored for us. That's helpful in finding the domain restrictions and the vertical asymptotes. Okay, what are the two things x cannot equal? X cannot equal -1 or +2. Is that confusing anybody from the denominator? Okay, so therefore there are vertical asymptotes at x equals -1 and another one at x equals 2. Now, just to throw this out there, because we're going to do this in a second, that's not always the case, because there could be a hole instead, but that would only be if there was also like an x minus 2 on the top and an x minus 2 on the bottom. Okay, otherwise it's always a vertical asymptote, but it can never be both a hole and a vertical asymptote. All right, and the horizontal asymptote. This is where I'm a little worried about some of you. Does everybody understand the degree of the denominator would be what? 2. Because it would be an x squared if we fold it back together. They just gave it to us factored. Okay, so this is degree 1 in the top, because there's just one power of x, but in the denominator, if we fold that back together, we'd have an x squared, so it's degree 2, which makes it bottom heavy, which approaches 0. Yay. How we doing? Okay. I think we get to talk about holes next. There's some extra stuff here. It says when the degree of the numerator is exactly 1 more than the denominator, you'll get an oblique asymptote or a slant asymptote, and you find that by division, ignoring the remainder. All right. If it is not, if you divide and you don't get a line, you could get a parabola or other function. Basically, any kind of horizontal, any of those things about top heavy, bottom heavy, and equal weight are all called end behavior asymptotes, because it is what the graph approaches at the far left and right. All right, this is an extra example. I'm going to go through this real fast just because this one is what? Top heavy. Does everybody see that? It has a degree 2 over degree 1. So top heavy, okay, you would factor the top. All right, I'm going to go through this quickly. You would say the domain cannot be -4 because of the denominator. So it has a vertical asymptote at x equals -4. So if I graphed it, I'd have a line over here at x equals -4. Then you would set the top equal to 0 to find, I should have set x equal to 0 to find the y-intercept. If you put a 0 in, you get -6 over 4, which is -3/2. So it crosses the y down here at -1.5. If I set the top equal to 0, where are the two x-intercepts? What would make the top 0, guys? I factored it for you. 3 and -2. Okay, top equal to 0. So over here at 3 somewhere and over here at -2, it's crossing. Then we go with this end behavior idea, or the fact that it's top heavy. Because it's top heavy, you divide. Okay, because it's top heavy, you divide and you get to ignore the remainder. Can we do synthetic division for this problem? Is x plus 4 a linear factor that, yes. So we would do a -4 across the top. We'd have a 1, -1, -6, because you use the unfactored form. Bring it down, multiply by -4, add is -5, and I really can be done because I get to ignore the remainder. So this is y equals 1x minus 5. So x minus 5 is the slant or oblique asymptote, which is also called an end behavior asymptote. So I don't know about you, but this seems pretty clear that it's doing this up here, okay? But there does have to be a piece on the other side of this asymptote. So if we graphed it on the calculator, and I won't take time, there is a piece down here, but if you don't see it in a normal window, you're going to have to go looking for it. See, I had to change my y value to find all of the graph. All right. Finally, we're going to talk about a hole. How are we doing on time? 2 minutes? Okay. We're not going to talk about a hole today. We'll save a hole for tomorrow. Okay. What do I have assigned? Okay. I think you were supposed to do the next page. You know what? I think you're actually supposed to do delta math and maybe the stuff on the next page. Start on delta math tonight. If there's any that say anything about a hole, just skip that problem and we can go back to it later. Does that make sense? Yeah. Here's my suggestion as well. Can you please do the 4 problems on the next page? Don't do them. Just factor them. Okay? If you get them all factored top and bottom, that'll get us started on the next part. Okay? So do the delta math tonight and then also work on, Cheyenne, this is a pass for you. Sorry. It's probably supposed to be 10 minutes ago, but maybe not. So do the delta math tonight, unless it says that it's about finding a hole, then skip that problem. And then do on that next practice worksheet in your notes, there's like 4 circled problems. Get those factored top and bottom, so that'll help us be ready. All right, thanks guys. Can anybody tell me the worksheet number for that next page? Is it 14A and B, 13? 13B and 14A, because the numbering's all off. Factor 4 circled problems on 13B, 14A. Oh, nobody got there. That's okay. We have time, right? We're not doing the retakes till next week for the remediation. Okay. Do delta math, and that is called 2.5 rational graphs. Okay.